We want to show you now how to splice two fibers together using a mechanical splice. The splice we're using is the ACA Ultra Splice. We use that for two reasons. One is that it's a very straightforward example of a mechanical splice, and the big advantage is it has a window on the top here that allows you to actually see the fibers inside the splice, which makes splicing very easy, and as you'll see later on, it allows us to optimize the splice quite easily. The first thing we have to do is we have to strip the cable, and this is just like for termination. We nip through the jacket, twist it, pull the jacket off. This time we will not need the Kevlar, so we'll cut the Kevlar off near the end of the cable jacket. Now we're going to cleave the fiber. So we're going to need to strip about 1.5 inches of the buffer off the fiber. We have to be careful when we're stripping so much to make sure that we hold the stripper at a 45-degree angle. We cut fully through the buffer each time, and that we smoothly slide the cut buffer off the end of the fiber. We're still taking bites of the buffer at about 3/16 of an inch each time, just to make sure we don't break the fiber. If we break the fiber, we'll have to start over. Okay, once we have about 1.5 inches of the fiber stripped, we'll take an Alco pad and clean the fiber, and now we're ready to cleave it. There are a number of different instruments that are made to cleave fibers. They sell for anywhere from $200 to $5,000. We're going to show you a simple way using an inexpensive cleave fixture and a simple scribe that works and can work fairly well if you're trying to do a quick restoration. We take this fixture, which is a small piece of flexible plastic on a rod, and you can see it bends down. Well, we're going to use that bending motion to hold the fiber, to scribe it or put a scratch on it, and then push down hard and pull away to break the fiber in a controlled fashion. So what we're going to do is we're going to place the fiber on the fixture with the length of fiber that we want protruding from the buffer on the center back to the buffer. Hold this with our fingers, and then just scratch the fiber right in the center, and then push down and away to cleave the fiber. The Ultra Splice has 2 knurl nuts on either end which lock the fiber in place. It also has small blue inserts on either end that are used for fiber that has only a 250 micron buffer. Since we have 900 micron buffered fiber, we will remove those blue inserts and discard them. Now we take our cleaved fiber and insert it into the splice, and watch the window so we can see the fiber as it inserts into the center of the window. You can actually see it through the window as it comes in. You'll have to do this one on your own because we can't get close-ups enough. When we've inserted the fiber to the center of the splice, we'll tighten the locking nut, and we've done 1/2 of the splice. Now let's strip the other fiber and cleave it. Exactly the same process. We'll strip off about 1.5 inches of buffer, so we'll have that much glass showing. Then we'll cleave it and finish our splice. Okay, I've got my fiber stripped. Take an Alco pad, clean the fiber, and use my cleaving fixture to cleave this fiber just like the other one. Notice I'm holding the fiber on the fixture with both fingers. I'll scratch the fiber and then just push down and pull away, and that will create our cleave. Sometimes if you don't put a scratch on it correctly, it won't cleave, so you have to go back and do it again. Once we've cleaved the second fiber, we'll clean it again, and just like we did before, we'll insert it into the other end of the ACA Ultra Splice. Take out the blue bushing, which we don't need, and then insert the second fiber. And now you can watch in the window and see the second fiber as it comes in and mates with the fiber that's already there. When you have it in all the way, tighten it up, and we have made a splice. Now you can test your splice as part of this patch cord. So you can just take this patch cord with a connector on either end and a splice in the center and test the loss of the entire patch cord. And what you'll be measuring, if you measure it, is the loss of the connectors plus the loss of the splice. Typical splice losses can be anywhere from very, very low to as much as a half a dB. The quality of the splice will depend completely on how well you cleave the fiber. But there's another way that we can test the splice by using a visual fault locator. A visual fault locator is a laser source that is visible. And I can turn on this laser source, and it's bright red, and we can actually see, hopefully, the light coming from this laser. What we'll do is we'll take this laser source and couple it into one end of our cable. And then we can actually look at the splice and see the splice and see the light in the splice, and the light that's lost in the splice will show up as visible light. So let's see if we can get a close-up of this and show you how it works. By putting visible light into the splice, we're able to actually see the loss of the splice. So we can see a small amount of light lost here. We're working in the dark, so it's not very much light at all. Or if we open up and increase the gap between the ends of the two fibers, you can see there's massive amounts of light. So as I push the fiber in and close the gap between the two, you can see there's just a tiny amount of light being lost. And that allows us to optimize the loss of the splice using the visual fault locator. This is a tool that, if you're doing a lot of splices, is absolutely the best thing going. You can also use this in connectors that have splices in them, the pre-polished splice type connectors, because most of them will show the similar kind of behavior when you are terminating them. Now you can see we've been working the fiber in and out and trying to minimize the light loss. You can see there's very, very little light loss now, but if I pull it apart, there's a tremendous amount of light lost. So that shows you how to optimize the splice, and that's one of the best tools if you have to do splicing.